Now that you've done the independent work and you might have a few questions, I'm going to walk through some of the main concepts that we covered with this worksheet from the book. So when we're talking about surfaces, the main thing to keep in mind is that we're really talking about three-dimensional shapes, and we're kind of thinking about these three-dimensional shapes outward part, almost a wrapping around them. That is the surface of the shape. If you ever hear something referring to the solid, it's talking about not just this outer wrapping or the outer formation of the shape, but also the filling that you could have within. Like if I took this and I filled it entirely with cement, that would be considered the solid. Now we're going to use a lot of different types of surfaces. So I'm going to go through each one and give you your key vocabulary words for them. And notice that the definitions that we're going to be using here are going to be in our own words. So these are not the official geometric definitions, they're just ones that are probably more practical to use. So for our first figure, we're looking at a sphere. Now, if you have to draw this sphere, you can take a compass and make a perfect circle and do this little curving line on the inside across the widest part of the circle, and that creates that idea or illusion of dimension on this two-dimensional paper. Now, the definition of a sphere formally is it's a set of all points equal distance from one center point. So it's this radius being spun around so that it hits every point on the sphere. Now, really, you can think of a sphere as basically our standard ball. And in it, you're going to have the center of the circle, which is that exactly central point that all of the points are equal distance from. And you're also going to have the radius. And the radius is like the radius of a circle. It's just a point that connects a point on the sphere to the center of the circle. Now, our next two we usually take together, and that is a cone and a pyramid. The reason why we take these together is cone is a broad term. All pyramids are just a type of cone. And cone just means that you have some sort of base. It can be a triangle, a circle, or even just like a weird formation like this last one. And you're going to build upwards to a central point. So it basically stacks up to that center point, and that point is called our vertex. You can think of these things like traffic cones or old pyramids. All of those are forms of cones. And in these, we're going to talk about two main things. We're going to talk about the base, which is that bottom section that builds up. And here's that bottom circular base, and our bottom, I guess it looks kind of like a pond over here. And we also have what we call a vertex, which again is that point that it builds towards. There's one other term that you're going to see quite frequently, and that's what we call a lateral surface. Now, a lateral surface is all of the lines or segments that connect a point on the edge of the base to the vertex. So all of these things that I'm shading in here, those would all be segments formed. And you notice that what you're actually making here is every part of that shape except for the base. And you can actually almost visibly take off the lateral surface. So if I took off all the lateral surface on this pyramid sort of shape over here, I'd end up with this pyramid, I'd end up with this pyramid, and I'd end up with this backside pyramid there. And my lateral surface would be all three of these, but it would not include the base. So you can kind of think of a lateral surface as everything but the base. And that's going to hold over for a pyramid. The lateral surface will be everything but the base, and we just saw an example here. Now, a pyramid is a specific type of cone, though. And a pyramid is a cone that has a polygon base. And in this, then, we're going to end up with some specific edges. And anytime they have this combination here of a vertice on the bottom reaching up to the vertex, that's called a lateral edge. So we have here 4 lateral edges, and you can see the one I marked over here. The base is still going to be that solid shape. You can usually recognize it as the one that is not a triangle. And you can also try to find your highest vertex there. It would be opposite of that. We also have another term. Not only do we have lateral surface, which is everything but the base, we also have what's called a lateral face. And a lateral face is just one of the sides that is not a base. So here we have a lateral face, this triangle. We have another lateral face along the front and along the side and along the back. And because we have 4 sides to our base, we're going to have 4 lateral faces. And the difference between face and surface is going to be all the lateral faces. It's going to be the combination of these 4 lateral faces. Like we saw over here, this one had 3 lateral faces, so its surface was all 3 of them. It just doesn't include the base. Moving on to our next terms, we've got cylinders versus prisms. Now, cylinders and prisms have a lot in common with cones and pyramids. And the first thing that they have in common is that a prism is a specific type of cylinder. So when we're talking about cylinder, we're really talking about a broad category here. Any picture that I draw for a prism is technically a cylinder, because all it really takes to be a cylinder is to have this single base that you stack on top of each other to reach an identical base along the top. And these can lean sideways, so like this whole thing might actually be at an angle where you're going to see something like this instead of that nice, lovely stacking. Think of it as like the Leaning Tower of Pisa here. But the bases still are going to be the same size, and the space between them is just connecting every point here to a point here. Now, I've already labeled my bases here, and you should be able to find 2 identical bases in each one. The lateral surface is going to be everything except for that base, just like it was for cones and pyramids. Except, of course, in this case, we have 2 bases instead of just 1. If you think about this in terms of our common cylinders, like a toilet paper roll, the lateral surface is really just the cardboard that forms that toilet paper roll. And there are no drawn in or made bases to that toilet paper roll because it's open and empty. If you were to cut it and lay it out, it usually forms a rectangle, or if you cut it several times, maybe a rectangle if you piece those things back together. Now, when you're talking about a prism, though, it gets a little bit more specific, because in this case, a prism is a polygon, or it has a polygon base rather than any base. And that polygon base gets stacked to form the full 3-dimensional prism. Just like before, that does mean we're going to end up with a lot more terms. We still have our bases. They're both polygons. Here we have a base that's triangular, and here we have a base that's a pentagon and a second pentagon over here. When we get to vertex, there isn't a single vertex. What we have is a lot of vertices. So you can see each of those marked in red. They're each of the vertices of the bases. So in my pentagonal prism over here, I have 5 vertices from one base and 5 from the other. When we're talking about lateral edge, the lateral edge is going to be the line that comes between a point and its corresponding point on the other base. So you can see each of these, they're going to get drawn in when you're making these figures. And those are each our lateral edges. They should all be equal in length. And last but not least, we still have lateral face versus lateral surface. Remember that lateral surface is everything but the base. So here, if I were to cut off all of the pieces and separate it out, I'd have the 2 bases, which I'd ignore because they're not part of the lateral surface, and I'd have 5 rectangles that form that lateral surface. Each one formed by this, all the way building up to this line over here. And it does make kind of like a rolled out rectangular shape if you were to combine all of them. Now, each of these little rectangles that I drew is considered a lateral face because it's just one of those sides that's not the base. Now that we have our main figures, what we need to talk about is oblique versus right. And when we're talking about oblique, all you're really saying is that something is tilted. So here, if I have a right cylinder, it's going to be coming at a 90-degree angle. So the angles formed between the bases here will be at 90 degrees, and they're stacked directly on top of each other. as opposed to oblique, where you have this lean as if someone has shoved it over, so that this does not come at that 90 degree and instead comes at some other angle. Similarly, a right pyramid and a right cone is going to have the vertex directly above the center of the base, and that forms that 90 degree angle that we like. As opposed to here, you can see that my vertex is not above the center of my base. It comes at this angle, and it makes it look lopsided and tilted. That means it has to be oblique. With each of these, when you're trying to draw them, start with your base. If you want it to be oblique, draw your vertex off to the side or below into the side, and then draw those connecting lines from the edges of the base, and that will make sure that your figure will lean or be oblique. Pentagonal prism, the last one, can be quite hard because drawing something that is a prism and making it look like it's leaning is difficult, since it just kind of looks like you're drawing it in perspective. So sometimes you need to indicate that what you're doing is not at a 90 degree angle, so you draw a 90 degree angle on the outside. Now with each of these, it's almost easier to understand right and oblique just by looking at a series of pictures. So I'm going to give you the answers to these. When we're looking at this one, we know it has to be right because the vertex is above the center of the circle, so that tells me it's a right cone. And here we've got an oblique cone, because if I were to take the center of this base, it'd be right here, and directly above that would have to be its vertex were it a right pyramid, but it's off to the side. This one has to be right because you can see it's hitting at 90 degrees to the base, 90 degrees to the base. These are stacked directly on top of each other. This one again has to be right because you can see that vertex is directly above the center. And this is again what they usually do for a prism when they want to show you that lean. They're going to drop a line down from one of the bases, set it equal to the plane that contains the other base, and just show you that that is a 90 degrees, so this could not be a 90 degree, and therefore this must be oblique. I'll leave the rest of them to you. Now we have one other definition to focus on, and that is, what does it mean when something is a regular prism or pyramid? If something is regular, all it means is that the base is a regular polygon. So all of the sides of the base and all of the angles on the base are going to be congruent or equal in measure. When you're classifying, regular can come in handy because it's going to give you more information than just saying, okay, well, I have a hexagon base. If you know something is a regular hexagonal prism, what that's telling you is that you'll have all these measurements that you'll be able to mark in. And we always want as much information as possible in geometry because it's going to let us solve a lot more things. When you're naming, you're going to go in this order. You're going to say right or oblique. So here we have a right figure. You're going to then call out its base name, and here this is a circular base, so I have a right circular. And then you're going to say cone, pyramid, cylinder, or prism. If it's a sphere, you can just say sphere. Those ones are pretty easy. So here we've got a right circular cone, because that's as specific as I can get. Here I've got an oblique or tilted, square, or if you want to be broader, you can call it rectangular, pyramid, sphere. Now in this one, I have a right, and then if I count the bottom sides, I have 6, so that's a hexagonal, or hexagonal, prism. And with each of these, you're just kind of replacing the end with the AL. So looking at each of these, just make sure that you are careful to go in that order and that you are really making sure that you don't mix up how many sides are along the bottom. As far as right goes, unless you actually see the markings drawn in, like if I drew in these for you, you don't want to call something regular because we can never actually tell from a picture. So even the square ones, technically you shouldn't be able to call those squares because we don't know that each of these sides are equal, but I'm going to let it go because we aren't really at that point in our lessons. The last page is a review from earlier, so you can go ahead and check out the answer key for that. I have written explanations for each one. If you have questions on those, further questions, do not be afraid to ask me. I will run through those and give you an additional video for just doing those. If you'd also like to see how to draw each of these figures, I can post an additional video for that as well.